Hello students, I am Ashish De. I am taking one of your subject, that is signal and system. In my earlier video, I have discussed about basics of signals, continuous time signal and discrete time signal. I have discussed about sampling and some components of a continuous time signal. Now today in my video I want to discuss about some test input signals. So some test input signals there are, the first signal is unit step signal. So first is unit step signal. Unit step signal. So from the name unit step, okay, unit means 1, okay, the value of the signal will be 1, okay. So the graph of a unit step signal looks like this. The value is 1, the magnitude of this signal is 1, and unit step signal is represented by u of t. Here is the time axis t, and it will starts from time t equal to 0 and goes up to infinity, okay. Time goes up to infinity. The magnitude remains same, that is 1, okay. So if I want to define unit step signal, it will be defined like this way: ut equal to 1 for t greater than equal to 0, right? For t greater than equal to 0, time either 0 or greater than 0, the magnitude is 1, okay. And this is 0, ut equal to 0 for t less than 0. So here we can see that when t less than 0, that means when t is negative, then there is no value of ut, okay. Ut is 0, right? So this is unit step signal. Now unit ramp signal, sorry, unit impulse signal, okay. This is actually this unit step signal is defined in continuous time domain. Again, it can be defined in discrete time domain, okay. In discrete time domain it look like this way. All amplitudes are unity. Along x-axis there is n, and here will be u of n, right? So the time, the value of n will starts from 0. So 0, 1, 2, 3, 4, like this way, okay. Since n is an integer value, so it will starts from 0 and up to goes to infinity, okay. So here is also un equal to 1 for n greater than equal to 0, 0 for n less than 0, right? So this is unit step signal. Now unit impulse signal. Unit impulse signal. The graph of unit impulse signal in continuous time domain looks like this. Suppose this is y-axis, along y-axis there is delta t. So unit impulse signal is defined by delta t. Along x-axis there is t, and this is 0th position, okay. So this is, suppose this is epsilon, okay. There is a small value epsilon. It is obviously in fraction, and it tends to 0. Epsilon tends to 0, and the magnitude is unity, right? So the height of the strip, this strip is 1 by epsilon, Okay, so this thing. Now delta t can be defined as delta t equal to delta t, sorry, this magnitude is not equal to 1, right? This magnitude is 1 by epsilon. Okay, and this duration along x-axis, along time axis, this duration is epsilon, right? So delta t equal to 1 by epsilon for 0 less than equal to t less than equal to 1 by epsilon, 0 otherwise. Okay, now the area of this strip is unity. Okay, since it's a rectangle section, the area will be epsilon into 1 by epsilon, that is 1. Okay, so the area under a unit impulse signal is unity. So area can be defined by integrating 0 to epsilon delta t dt. Okay, that is equal to 1 by epsilon into epsilon, so that will be equal to 1. Okay, so area under unit impulse signal is equal to unity. So this is the definition of unit impulse signal. In discrete time domain, if we want to define unit impulse signal in discrete time domain, it is called unit sample signal. Unit sample or impulse signal. In discrete time domain, the graph of this unit sample signal looks like this. This is 1, this value is 0, here is n, right? So this is delta n. Now delta n equal to 1 for n equal to 0 and 0 for n not equal to 0. See here, when the value of n equal to 0, then only delta n equal to 1. When n has some values, either 1, 2, 3 or -1, -2, 3 like this, then delta n will be equal to 0. So this is unit sample signal or unit impulse signal in discrete time domain, right? Now number 3 is unit ramp signal. Unit ramp signal. So the graph of unit ramp signal is this is the time axis, and unit ramp signal is defined by r of t, right? The graph is this. Okay, this angle is 45 degree, right? So this is starts from time t equal to 0. If we want to define rt, then rt will be equal to t for t greater than equal to 0, right? And this will be equal to 0 for t less than 0. So this is unit ramp signal. Okay, when t greater than equal to 0, then it has the value t. Okay, it increases with time t. Okay, and for t less than 0, the value is 0. Okay, so this is unit ramp signal. In discrete time domain, unit ramp signal looks like this. Okay, so this is 0, 1, 2, 3, 4, 5, like this way. This is the value of n, and this is r of n. Okay, so 1, 2, 3, 4, 5. Here is also r of n equal to n for n greater than equal to 0, 0 for n less than 0. Okay, so this is unit ramp signal in discrete time domain. Okay, now number 4 input signal is unit parabolic input signal. Unit parabolic input signal. Okay, unit parabolic input signal the graph of unit parabolic input signal is this. This is 0, time t is 0 here, and here is it can be represented by x of t, right? So x of t can be defined like this way: xt equal to t square by 2 for t greater than equal to 0, and this is 0 for t less than 0. Okay, so this is unit parabolic input signal. Now in discrete time domain, the graph of this signal looks like this way. This is n and this is x of n. Okay, so here is also xn equal to x of n equal to n square by 2 for n greater than equal to 0, and 0 for n less than 0. So this is unit parabolic input signal in discrete time domain. So here we can see that unit step signal is a time derivative of unit ramp signal, and unit ramp signal is time derivative of unit parabolic signal. So from this video, what we learn? We learn about some test input signal that can be applied to any system. Okay, they are unit step signal, unit impulse signal, unit sample signal, that is in discrete time domain, unit ramp signal, unit parabolic input signal, and the relationship between them. Okay, so that's all.